This is section 3.3 on trigonometric substitution. Here's a table of the trigonometric substitutions you'll make if your integrand involves a squared minus x squared, a squared plus x squared, or x squared minus a squared. You don't have to memorize this table, by the way. After you make your substitution, the first thing you're going to do when you solve a problem is you're going to fill in your triangle. And so on this first page, I just want to show you step one without doing any integration. So suppose you make the substitution x equals 2 sine theta. Here's how you would fill in the triangle. Solve for sine theta. Sine theta is x over 2. And sine is opposite over hypotenuse. And so the side opposite the angle is x. And the hypotenuse of the right triangle is 2. How do you get the third side? Well, you use the Pythagorean identity, which I have up here at the top. If this is b, I know b squared plus x squared is 4. So b will be positive the square root of 4 minus x squared. Positive because we're in quadrant 1. So I'm going to replace this with the square root of 4 minus x squared. Now let's simplify the square root of 4 minus x squared by writing it in terms of theta. So I'm going to replace the x squared with 4 sine squared theta. Now this is going to simplify, and once you do enough of these problems, you won't have to write down all the steps. You'll just jump to, oh, that's 2 cos theta. But I'll show you how I got there. First, factor out the 4, 1 minus sine squared. And then in every case, you're going to use a Pythagorean identity to simplify. And I have the 3 Pythagorean identities listed at the top. 1 minus sine squared is cosine squared. So this is square root of 4 cosine squared theta, which is 2 cos theta. You don't have to worry about absolute value because of this fine print right here. So that's the first one. Now let's do another one. If x is 3 secant theta, fill in the triangle. So this time, solve for secant theta. That's going to be x over 3. Now secant is hypotenuse over adjacent. So the hypotenuse is x, the adjacent is 3, and I can fill in this side. Once you do enough of these, you'll jump right to, oh, that's x squared minus 9. But if you can't do that in your head, just call it maybe b, and use the Pythagorean theorem. 9 plus b squared is x squared, and then solve for b. Take positive the square root. B is the square root of x squared minus 9. All right, simplify x squared minus 9 square root. So again, replace x with what it is, 3 secant theta. So I square that, I get 9 secant squared theta minus 9. Factor the 9 out. Secant squared minus 1 is tangent squared. So this is the square root of 9 tangent squared theta, which is 3 tangent theta. All right, we'll just do one more. If x is 1/2 tangent theta, fill in the sides of the triangle. So solve for tangent theta. Tangent theta is 2x. I want to think of that as a fraction. So 2x over 1. And then tangent is opposite over adjacent. So this side is 2x, this side is 1, and I can fill in the hypotenuse using Pythagorean theorem, and I get square root of 4x squared plus 1. So now let's see how to do a complete problem. The steps are, step 1, make your substitution, make your triangle, and don't forget to find dx, and I'll show you what that means in a moment. Simplify your integrand. We practiced doing that on the previous page, but then go ahead and integrate, and we'll do that in the next example. And then the reason you make a triangle is because for step 3, you're going to use that triangle to rewrite your answer in terms of x, not in terms of theta. So with this example here, we've got 1 over the square root of x squared minus 9. So we go up to our chart and we look for what substitution to use in the case that we have an x squared minus a squared. And if you look in that chart on the previous page, you'll see that we want to make the substitution x equals a secant theta. In this case, a is 3. So we're going to let x equal 3 secant theta. Dx is the differential form of the derivative. So that's 3 secant theta tangent theta d theta. All right, and then to fill in our triangle, we did this on the previous page. Solve for secant. Secant theta is x over 3. And so we had x here, 3 here, and this was the square root of x squared minus 9. And now we're good to go for step 2. We replace everything in terms of theta. So the dx gets replaced with 3 secant theta tangent theta d theta. And we replace square root of x squared minus 9 with square root of 9 secant squared minus 9. Now, we've already done that simplification on the previous page. We know that this simplifies to 3 tangent theta. So our new integral is the integral. We've got 3 secant theta tangent theta on top and a 3 tangent theta on the bottom, d theta. The 3's cancel, the tangent thetas cancel, and we're integrating secant theta d theta. Okay, well, we know that that is ln of the absolute value of secant theta plus tangent theta plus c. Okay, now we're up to step 3. We want to leave that answer in terms of x, not theta. So what we're going to do is read secant theta and tangent theta right off the triangle. This is ln absolute value. Well, secant theta is x over 3, and tangent theta, tangent is opposite over adjacent, so that's the square root of x squared minus 9 over 3 plus c. And there you go. There's our final answer. Okay, let's do another one. I've done parts of it for us. It's a little bit long. We've got the square root of 4 minus x squared. So we go to our table, we say, all right, if it's, involves a squared minus x squared, the table says let x equal a sine theta. A is 2 in our case, so we're going to let x equal 2 sine theta. So dx is 2 cos theta d theta. And to fill in our triangle, I get sine theta is x over 2. So the opposite is x, the hypotenuse is 2. And by Pythagorean theorem, the missing side is the square root of 4 minus x squared. All right, so I made the replacement already. I replaced 4 minus x squared with 4 minus 4 sine squared theta. I factored out the 4, and I replaced 1 minus sine squared with cosine squared. This is dx. That's where that came from. Then take the square root of 4 minus cosine squared. You get 2 cos theta. So you end up with 2 cos theta from your square root, and then a 2 cos theta from your dx. Altogether, that's 4 cosine squared theta. All right, fortunately, we did a section on how to integrate powers of trig functions, and we know that in order to integrate cosine squared, we have to use the half angle formula. So I replace 4 cosine squared with 2 plus 2 cos 2 theta. And then finally, I can integrate. If I integrate, I get 2 theta plus sine 2 theta plus c. All right, now I want to go back to my triangle to do step 3 and write everything in terms of x. But the problem is, I don't have a triangle for 2 theta. I have a triangle for theta. And so I need to write my answer in terms of theta, not sine 2 theta. So anytime you have to use the half angle formula in order to integrate, you're going to have to use the double angle formula to simplify your answer back in terms of theta. So this is 2 theta, and then sine 2 theta, the formula of the double angle says that's 2 sine theta cos theta. So now I can use my triangle because everything's in terms of theta. All right, so that gives me 2 and then theta. Uh-oh, what's theta? Well, if you end up with just a plain theta in your answer, you're going to get an inverse trig function. So let me go over here. We got sine theta is x over 2. So that tells us theta is sine inverse of x over 2. Take arc sine of both sides to solve for theta. So this will be 2 sine inverse x over 2 plus 2 sine theta. All right, back to my triangle. Sine is opposite over hypotenuse. So x over 2. And then cosine is adjacent over hypotenuse. Square root of 4 minus x squared over 2 plus c. So these two cancel, and I get 2 sine inverse of x over 2 plus 1/2 x times the square root of 4 minus x squared plus c. Next one is a definite integral. If you have a definite integral, you can change your limits and you don't need to go back to x's. So you actually don't need to make a triangle if you're doing a definite integral. So step one, we've got an a squared minus x squared. So we're going to let x equal just plain sine theta dx cos theta theta d theta. All right, typically I would make a triangle, but if it's a definite integral, you don't have to, but you do have to change your limits. So the way to change your limits, you're going to need to solve for theta. So sine theta is x. So theta is sine inverse of x. Take sine inverse of both sides. That's what I have in my table here. So when x is 0, theta is sine inverse of 0. Theta equals sine inverse of 0, which is 0. And then when x is the square root of 3 over 2, theta is sine inverse of the square root of 3 over 2, which is pi over 3. So our new limits are 0 to pi over 3. And I started out the calculations for us. On top, I have 4x squared. So I took 4 sine squared theta. And then in the denominator, I've got 1 minus x squared to the 3/2. 1 minus sine squared is cosine squared, and that's to the 3/2. 3/2 times 2 is 3. That's how I ended up with the 3 right there. And then the cos theta d theta is from my dx. So altogether, if I simplify, that's going to be 4 sine squared theta over cosine squared theta, and my new limits are 0 to pi over 3 d theta. Okay, that's the integral from 0 to pi over 3 for tangent squared theta. The way to integrate tangent squared is to use a Pythagorean identity and write it in terms of secant squared. So this is going to be 4, and then tangent squared is secant squared minus 1 d theta. So you can distribute the 4 and then integrate. That's going to be 4 tangent theta minus 4 theta between 0 and pi over 3. So we get 4 tangent of pi over 3 minus 4 pi over 3. And then when I put in 0, tangent of 0 is 0, so I just get 0. And so final step, tangent of pi over 3 is the square root of 3, so this is going to give me 4 root 3 minus 4 pi over 3. Okay, one more problem, and it's fairly short. Solve the IVP. An IVP stands for initial value problem, and so this means find y. And we're given y prime is 1 over x squared plus 25. So we're given the derivative, we have to find y. So when you're given a derivative and you want to get the function back, what you do is anti-differentiate. So y is the integral of 1 over x squared plus 25. Now you could do a trig sub on this using your table. So it's a squared plus x squared. Let me scroll up here. The table would say let x equal a tangent theta. However, you'll end up in the same place if you just use, this is a Bible formula right here. This is just 1/5 tangent inverse of x over 5 plus c. And so if you did a trig sub, you'd go through all the steps and like 10 minutes later, you get the same answer. So that's step 1, is to find y when you're doing an IVP. Step 1 is to find y by integrating. Step 2 is to find c. Okay, so we're going to find the constant using the fact that y of 5 is 0. Put 0 in for y and 5 in for x. 1/5 tangent inverse of 1, because 5 over 5 is 1. Tangent inverse of 1 is pi over 4. So we get pi over 20 plus c. So that tells me that c equals negative pi over 20. And then step 3 is to put steps 1 and 2 together. Step 3, you want to answer y equals with no constant. And so you combine these two steps, just plug in the c. So y equals 1/5 tangent inverse x over 5 minus pi over 20. So that's the end of this section.